Elastic versus inelastic collision in terms of kinetic energy. It is a known fact that the kinetic energy of any system under collision will have large impact over the collision irrespective of its type. They usually aid in deciding the kind of collision they are put. Also, the kinetic energy of the considered isolated system is conserved in a process of an elastic collision, but certainly not in a process of an inelastic collision. During an elastic collision, when the particles collide with each other, they have their own kinetic energy and are exchanged during the collision. So by doing this way, the energy is not lost after the collision and also conserved. Basically, when there is no exchange of energy between the particles, there is ultimately a loss of kinetic energy in the system. This is concerned to be the process of an inelastic collision. So in this way, we can really tell the comparison of elastic versus inelastic collision. Let us see some examples that will help us understand better the difference between elastic and inelastic collision. So taking the instances into consideration, we might know how the decision is made during the collision process, whether it is elastic or inelastic. Example for elastic versus inelastic collision in terms of energy. There is a simple difference between elastic and inelastic collision apart from energy and momentum. When these conditions are looked closely into, the minor difference between the elastic and inelastic collision is determined. When there are two rubber balls, we allow them to collide with each other. Once there is a bounce experienced during the process, then it is said to be an elastic collision because the balls do not stick to each other. Therefore, the energy and momentum are conserved in this type of collision. Similar way, when the balls are allowed to collide with each other, and the ball does not bounce, ending up sticking to each, then it is regarded to be the inelastic collision. Therefore, we come to conclusion of saying that the energy and momentum of the ball is certainly conserved. Elastic versus inelastic collision in terms of momentum. The elastic collision has momentum and energy conserved, but inelastic has only momentum conserved, whereas the energy is lost in the other forms such as heat, sound, and sometimes friction too. Momentum is the amount of force that is applied to a body for its further motion when the speed changes. The strength of the force on a body is basically regarded as the momentum. So in an elastic collision, when two particles collide, they do not lose momentum. But in an inelastic collision, the momentum is undoubtedly conserved, but the energy is lost because of no exchange happening in the process. Hence, the momentum of any moving body before and after the collision is said to remain constant. Example of elastic versus inelastic collision in terms of momentum. For example, when two cars bump over each other during an accident, there are several elastic collisions and inelastic collisions take place. Firstly, the momentum of the cars before collision will have an amount of force, but when the cars collide with each other, the momentum will change. The energy after the collision is not the same as the one before the collision because there is a sudden strike, so they exchange kinetic energy. The energy that has been lost in an inelastic collision will take different forms, and it can be heat or sound. Also, when the energy is exchanged, there is a possible way for an elastic collision. In simple words, in an elastic and inelastic collision, there will be no loss of momentum, and it is conserved totally. But energy loss depends on the collision type. Understanding the difference between elastic and inelastic collision. We must be aware of the examples to understand better how the elastic and inelastic collision works in terms of energy and momentum. There are types of elastic collisions when we go deep into the topic of elastic and inelastic. First is the superelastic, perfectly elastic, and then comes the partially elastic, which is also named after the inelastic collision. A superelastic collision is one in which the potential energy of the body is converted to kinetic energy, and then the motion of the body is carried forward. So, here there are fewer chances for energy and momentum to be certainly lost. In a perfectly elastic collision, there is no conversion energy occurring, and due to this very fact, momentum also has not been lost and is certainly conserved. The comparison of elastic and inelastic collision can be determined through this process. The partial collision is also regarded as the inelastic collision, where the energy is definitely lost in the process, and the momentum is not much lost, because it is the amount of strength of the force applied on the body for it to move forward. Frequently asked questions. Is bouncing ball elastic or inelastic collision? The process of a ball bouncing is certainly elastic collision because of the very act of bouncing. When a ball is dropped and bounces back to the starting position, it is said to be elastic. Due to the bouncing action, the ball does not stick to the ground. There is an effect of gravity in the whole process. So when the ball does not stick to the ground, there is no momentum lost, and energy is also not lost. This action is proof that the bouncing ball is an elastic process. What does hitting a baseball illustrates in terms of the elastic and inelastic collision? The baseball theory is definitely to be an elastic collision due to the fact that there is no external force acting. Since we know that there is no external force acting between the bat and the ball, there will be no loss of energy and momentum. And so the energy and momentum will be conserved in this collision process. The bat hitting the ball is considered to be elastic since there is momentum conserved after the hit. Also, energy is exchanged between the bat and the ball. No third party enters to influence the collision process. In which collision is momentum conserved? Momentum, as we know, is a quantity that measures the strength of the force, which is conserved on both the collision types. Momentum basically decides the amount of force that is needed to apply to the body in order to continue the motion with a changed velocity. The momentum at all costs will not change in elastic and inelastic collisions. One crucial fact to be noted is that the momentum is conserved in all the collisions is the linear momentum since the motion is in a straight path. Is angular momentum conserved in an inelastic collision? Irrespective of the collision, the momentum will be conserved whether it is linear or angular. The momentum will change the definition according to the path in which motion follows. When the motion is elastic or inelastic, the momentum will be conserved. Regardless of the path of the motion, whether circular or linear, the momentum will be conserved. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.